Good morning and welcome to another session of me working on Drakon Renderer. Today I wanted to introduce you to a little twist I thought about during the weekend. Last time I worked on Drakon, I was so fixated on using the directed graph type in order to render connections between positioned icons that I just didn't think of leveraging positioned icons themselves as a type in order to infer information about the connections that would be required for the renderer. And after having thought about it for a little while, I realized that using positioned icons should be perfectly doable for this purpose. So I slightly reworked this function, render all icons, and it used to be, I think, render all, and I reworked this. It used to be render, I think, single connection. Now it's render all connections. So remember the idea I had last week. The rendering is going to take place in two passes. For the first pass renders icons, and the second pass renders the connections. So I ran a little test during the weekend where the render all connections function gets single starting positioned icon and a list of end positioned icons to connect to, and the result we get is very straightforward and incorrect from the perspective of Drakon, but we do have a connection as so. Let me zoom it in. Yes, so the code says for the starting icon second, this is the 2, connected to icon third, 3, and 6th, which is this one. So obviously Drakon does not allow diagonal lines like this, but it doesn't matter for now. All that matters is that we have connections. So my plan for today is to flesh out this function a little bit so it goes through the entire collection of positioned icons, which we have available here. It takes all of its dependencies and creates connections for those dependencies. I'll be working on that today. So let's get to work. It should be an interesting time today. I have my coffee. Let's go. So this is the new function. And technically we'll only ever be using this and this implementation of it, where here we only have one icon to connect to, and here we can have more than one. This one is just for the sake of the compiler not complaining that the implementation is incomplete and the patterns are not exhaustive. This produces an empty diagram, but in practice this will never be called, because why would we be calling render all connections for an icon that does not have any connections? But famous last words. Let's see what happens. For now the compiler is not complaining about it. I only have one icon here, but it would be nice to go through all available positioned icons and call this function for all those positioned icons. So we'll be looking for a function like this. to go through all positioned icons. And we'll just return a diagram. It complains about the new function, but it does compile. That's fine. And there are a number of warnings in the main function because I'm doing this travesty. But, you know, please excuse me. This is just for the time being. Okay, now I just need to figure out this function. Let's worry about the names later. So here we'll need to find positioned icons in the collection of positioned icons that also happen to be dependencies of this positioned icon. So technically, positioned icon needs another, sorry, dependencies needs another argument that is the collection of all positioned icons to select dependencies from. You know what? This can be probably represented a bit better, not as three separate functions, but as a list comprehension. Okay. Okay, so now dependencies needs a full collection of positioned icons. It's fine. Oh, sorry. Oh, that will work. Yeah. We need to fold them. Okay, so the accelerator is the result of combining all the diagrams, and X is a single diagram. Let's see if this works. Okay, 84. That looks good. Oh, lovely. So we can simplify the fold a little bit. Yeah, I don't know why I thought the fmap or map would work. We need to fold the list into just one value of a diagram. Okay. So technically, I think this function is in its final shape. Let's start worrying about the names. So this function that renders all connections of a single positioned icon, we're going to render connections. And the type is pretty straightforward. At render all connections, it's going to render all connections of a list of position icons. Now let's make sure we're calling the right thing. But here, we're no longer interested in this abomination. Let's just use positioned icons. It will work fully, but that's okay. Now we can remove this. And look how elegant the rendering passes are starting to look. Render all icons, positioned icons. Render all connections, positioned icons. Okay. So if I was to read this for the first time, I would immediately grasp that we're rendering SVG with SVG options, where two passes need to be made: icons and then positioned connections between those icons. Let's build it. Now, what we need to figure out now is how to get the dependencies of positioned icons. So if I'm not mistaken, every icon already has a function that gets its dependencies. Get icon names of dependent icons. That's it. Now this will get me a list of string, and based on that list of string, I need to I need to go through this collection and return the positioned icons where the name is equal to the string. Let's see if I have a convenience function for that already. This is for the graph. So see, no, this is for the nodes. See, so here I'm thinking, but this is a question for later. The question I had over the weekend is, do we really need the directed graph type? Technically, what we use it for right now is to pretty print the provided input as a graph. But can we live without this? Absolutely yes. And also, we use it for Cartesian positioning of the graph. We basically sort topologically the graph, and we take the first icon, meaning an icon that nothing connects to, or icon not being a dependency of any other icon, which we can easily do without using the directed graph. So probably an exercise for later would be to try and to get rid of the directed graph type from the entire repository. We technically don't need it. We might need it later if we want to, say, detect circular dependencies or do some operations on graphs. But for what we're doing right now, I don't think this is needed. It is working well though, so let's set it aside. For now, our worry is to filter out those positioned icons that are identified by those strings. A very similar function already here. All right. So dependencies, all positioned icons. Get here. Sorry. So we're interested in those positioned icons. where their key is equal to the dependencies of this position diagram. And let's see what the key means. Key is not a term that we could apply to a positioned icon. Positioned icon has name. Oh, this function is wrong. I must have produced it by accident yesterday. It is clearly just copied this function. It is clearly this function just copied and renamed. Let's try to make a good use of it. Okay. We can't use this name, so let's come up with something compact yet descriptive. Something like this. And I'm not the biggest fan of this function. Probably go to a separate file. It's getting crowded, and we could really use the same name. I'm sure you can't use the same name. Yeah. Let's just use a prayer and leave a comment. X does not have a key. That way, since we have this, you know what? This is forced convenience. There we go. That should work. All right. Looks like a good tip. Reduce. I'm not seeing any difference, but let's look again. Ah, so it doesn't need all positioned icons. Okay. Oh, that's true. Mm, that it? All right. Let's see what this is. So this looks correct. 2 is connected to, oh, you know what? maybe. Let's just open the browser. And let's find this. So the layout should look something like this. 1, 2, 3, 5, 8. 1, 2, 3, 5, 8, which is the end. 2 connects to 4, connects to end. 2 connects to... Can I zoom it? 2 connects to 4, connects to end. Okay, that's good. 3 connects to 7, connects to end. 3, I'm not sure if we can see anything. 3 connects to 7, connects to end. 6 connects to ABC, and each one of these 3 connect to the end. 6 connects to A, B, and C, and all these connect to the end. And 3 connects to 6. Yes. Oh, we do have connections. They're not very idiomatic because the lines are diagonal, but we do have connections, which is pretty good. So we can polish it up later. For now, I think we can move this whole thing to records. Right. It still complains about the head. I'll have to do something with that warning. I want the code to work like that. Now, can we break this up into something more readable? It's X. This replaced with X. Make the code so much more readable. And let's call this all position types. This is X now. All position icons. Does look better, I think. All right, so for today, I think I'm happy with where we are. During the next session, we'll have to figure out how to make those lines a bit more drakon friendly. They can't be diagonal like that. But we do have connections. and that's not nothing. I spent a bit of time thinking about circular dependencies, which could happen in drakon, but the way both icons and the connections are rendered, I don't think we'll ever get stuck in a rendering loop because we go on through a finite list of icons when we render icons. And we do the same process when we render connections. We iterate through the finite list of positioned icons. For each icon we get dependencies and just one level of dependencies. And we just render connections for the parent icon and the dependent icons. I just can't see how we could be stuck in a rendering loop the way things work right now. But I could be wrong. Time will tell. For now, let's just see which branch we're in. A bit of admin. We are not on the right branch. Work in progress. Oh, I just want the name of the branch. Okay. Let's be very complex, so let's approach it slowly and maybe generalize where, if possible, later. 1. Only connect icons positioned as follows. Oh. So we sort of started with the general idea of connecting everything, and while everything is corrected, it's not really idiomatic drakon. So what we are going to do now is I'm going to focus on correcting those diagonal lines to follow drakon principles more closely, and I'm going to focus on this type of connections where we have parent on top and the child directly underneath it. And it's just a one-to-one relationship, meaning a parent cannot have more than one child. So a good example would be this relationship, or this one, or this one. Okay, but we'll get to it. For now, bit of cleanup. Okay, so this is good enough for now. Thank you very much for your attention today, and yeah, see you next time.